Hi there, we've got lesson 10.1d using the Pythagorean theorem. Today we'll be applying the Pythagorean theorem to some new situations. So let's get started.
Problem 1, find the distance of line DC. Fill DC in your notes. Now think about this problem, 8th graders. We are given a quadrilateral here on a coordinate plane. If we need to find the distance between 2 points, don't you think we could use the distance formula, which uses 2 points to calculate the space between them? Yeah, remember that distance formula is x2 minus x1 squared plus y2 minus y1 squared. What are we missing, though, in order to be able to substitute values into that formula and solve for the distance between the 2 points? We need some coordinates. You got it. So let's figure out the coordinates for point C there. What would be the ordered pair that represents that? 5, 7. And how about for D? Point D, what coordinate represents that? 2, 1. All right, let's substitute our values in to that distance formula. Remember, it doesn't matter which one of these you refer to as x1 or x2. What matters is that you are consistent when it comes to the x's and the y's. What do you mean by that, Ms. Kluver? Well, let me show you. I'm going to refer to this one as my x2 and this one as my x1. So it's going to be 5 minus 2, and I'm going to square that. And since I referred to this as my x2, this needs to be my y2. 7 is going to be my y2, and 1 is going to be my y1. So 7 minus 1, and I'm squaring it. All right, let's simplify inside those parentheses first. Redraw my square root here. 5 minus 2 is 3, so I'm going to go ahead and write 3 squared in. Plus 7 minus 1 is 6. I'm going to go ahead and write 6 squared in. All right, let's keep simplifying. 3 to the second power is going to give me 9. Plus 6 to the second power is going to give me 36. We need to simplify inside our square root there. 9 plus 36 is going to give me 45. I need to take the square root of 45. Let's round that to the nearest tenth. Go ahead and figure that out. I get about 6.7 units apart. That is the distance between those 2 points. Now, could we have used the Pythagorean theorem? Absolutely. We could have drawn a right triangle here, right? Can you see where my red highlighter came in? But we also have this beautiful quadrilateral already laid on a coordinate plane. We can apply the distance formula because we know the distance formula and the Pythagorean theorem are one and the same.
Here we have the equilateral triangle problem. Do you notice that the word equilateral kind of starts out like equal? If you're given anything about an equilateral triangle, you have to know that the sides of this triangle are all equal. They're the same length. So if it tells us that an equilateral triangle has a base of 16, we also know that all the sides would have to be 16. We're asked to find the height of the triangle. Remember, if you're trying to measure height, you're straight up and down. So that would be this part right here. Straight up and down, how high is this triangle? Well, I could figure out the height of the triangle by using the Pythagorean theorem. But remember, the Pythagorean theorem only works with right triangles. So what I would have to do is to create a right triangle that has the height in it right here. So here's my 90 degree. I know that the hypotenuse is 16. I'm trying to find the height, but that means I need to know how long this side is. Well, if the entire length is 16, wouldn't that just be half of it? So now let's find the height. The 2 sides that make the 90-degree angle are A and B. So we'll just call this missing part A. That's the height. Starting out with the Pythagorean theorem, B is 8. 8 times 8. So 16 times 16. All right, remember our goal is to find the A. Subtracting these two, getting 192. The last step is to take the square root. The square root of 192 is irrational. So if I use my calculator, I can approximate it. 13.8. And that next 5 here, I think we'll have to bump it up to a 6. So about 13.86 units. And remember, A was our height. So this is our height. This is how tall it is. Oh, actually, it says inches. So this would be inches. 13.86 inches. Now remember, the hypotenuse is the longest side. So the height here would have to be less than 16, which makes sense. So that's what we would do with an equilateral triangle problem. On number 3 here, we have a rectangular rug. Notice how this problem doesn't come with a picture. It says the area of a rectangular rug is 63 feet squared. The length is 9 feet. What's the length of the diagonal? It's difficult to picture this without a picture. So it might be a wise idea to draw what this is looking like. We have a rectangular rug. Let's draw a rectangle. It says the area of the rug is 63. Good to know. It tells us the length is 9 feet. Well, length is the long side. So from here to here, this is 9 feet. And it's asking us, what is the length of the diagonal? Well, the diagonal through a rectangle would look just like this. How long is that diagonal? That's what we're trying to find. Well, you need to think right triangle. Can you see it? Could I make a right triangle right here? Absolutely. Here, here, and right across there. I want the diagonal, which is the hypotenuse, which is C. But that means I'm going to need to know the other two sides. I know this is 9, but what's the width? Well, this is where the area is going to be important. It tells us the area of the rectangle is 63. And to find an area of a rectangle, it's length times width. So 9 times what number is 63? Yep, you got it, 7. So this is a 7 by 9 rectangle that has obviously an area of 63. So now I know what the two sides are. See, a picture is very helpful here. Let's use the Pythagorean theorem and find the length of the diagonal. A and B make the 90-degree angle. Square, square. Then just evaluate. 7 times 7, 9 times 9. If you add them together, you get 130. Obviously, this isn't 130 feet. I'm not done yet. Remember, I want just C. So square root. Same thing over here. The square root of 130, that's irrational. So I'm going to approximate it. On my calculator, it's about 11.4. Now remember, that should be the longest side since it's the hypotenuse, and it is. So we'd have about 11.4 feet. There we have the length of the diagonal. Remember, with a problem like this, if they don't give you a picture, it's a really good idea to draw one and label all of the parts, and then it's much easier to see what you need to do.
Problem 4. The point -3, -6 lies on a circle. What is the length of the radius of this circle if the center is located at 9, -2? We are trying to figure out the length between these 2 points. We have the center of the circle and the outside edge. That creates a radius. A radius is a segment that goes from the center of the circle to the outside edge. Do you remember that? So what we are trying to figure out is this distance right here. Do we have a formula that helps us calculate the distance between 2 points? Absolutely. Let's go ahead and let's use that distance formula to calculate this length right here with that neon green line. All right, let's get our square root set up here. Now remember, when you're taking your x values, it doesn't matter which one you say is x1 or x2. That doesn't matter. You just have to be consistent when moving to your y's. So I'm going to let -3 be what I do first, and I'm going to take away that second x value there, which is 9. So then when it comes to my y's, -6 needs to come first, and I'm going to take away -2. Okay, let's go ahead and let's simplify inside that radical sign there. So -3 minus 9 is going to give me -12 plus -6 take away a -2. Well, those two negatives turn into a positive. That's going to give me -4, and then I'll square that. Continuing to simplify, I hope you're staying with me. -12 raised to the second power, well, that's going to give me 144, plus -4 squared, that's going to give me 16. Continuing to simplify, 144 plus 16, that's going to give me 160. And I know 160 is not a perfect square, so I'm going to have to do some rounding. Let's round to the nearest tenth again here, okay? Go ahead and calculate what is the square root approximately of 160. I get 12.6, and now this is a length, and we don't know what specific units these are, so let's just write units. What is the length of this radius right here? It would be about 12.6 units. And we did that by using the distance formula. Now, could we have used the Pythagorean theorem? Can you see a right triangle? Yeah, and we could figure out this length right here, and we could figure out this length right here, and then calculate our hypotenuse, which would be my green line right there. Since we were given 2 points, I think the distance formula was a good choice.
All right, moving on to number 5. Here we have a picture of a garage, a square garage, square house. And it looks like we maybe have a little yard here. And in order to keep the dog in, we've got to put a fence along this side. It asks us to approximate the length of the fence. So how long is this fence right here that's keeping our dog in? Well, it looks like it's diagonal, and I could probably make a right triangle out of it. And if I solve the right triangle, I can find the length of the fence. Here's my 90-degree angle. But if I'm solving for the fence, which is side C of a right triangle, I have to know what the other two lengths are. Do you see how you could find them? 42 feet here, which means this is 42 feet here. If this is 23, so is this. There we go. There's my A and B. So let's use the Pythagorean theorem and find the length of the fence. You should be able to type all of this into the calculator. It will tell you 2,293. And that's not how long the fence is yet. Square root. Square root. Calculator is saying that this is approximately 47 point, I think we'd have to go about 8-9. And that's side C. Now this should be the longest of the three since the hypotenuse. It makes sense that that's longer. And this is just feet. So the fence is about a little more than 47 feet. And that's how you'd solve a problem like this. Next one we see here is a trapezoid. We're asked to find the height of the trapezoid. Remember, when you're measuring height, just like the height of yourself, you want to be standing straight up and down. So these two right here, the straight up and down, that's the height of the trapezoid. Remember, everything's related to a triangle somehow. So how could I figure out the height of this trapezoid? How tall is it? Well, here's a right triangle. I could solve the right triangle. Here's my 90-degree angle. I could figure out this height very easily by solving the Pythagorean theorem. These two sides make the 90-degree. So here's your A and your B. 17 is the C. I'll call 8 the A. 17 is the C. And then I just want to evaluate. So 17 times 17, 289. If I subtract here, I get 225. And of course, the last step, taking the square root. So B is going to be the square root of 225, which is exactly 15. So if I come back up to the picture, the height from here to here is equal to 15 units. Which makes sense, because remember the hypotenuse should be the longest leg. So there's the height of the trapezoid. And in order to figure it out, we used the Pythagorean theorem. All right, number 7. Let's take a look at what they're asking. Roadways N and M start at the same point and are perpendicular to each other. Roadway N is 44 meters long, and the distance between the endpoints of N and M is 125 meters. How long is roadway M? Now notice that we have no picture. When you get to a problem like this and there isn't a picture, you need to create one so that you have something to look at and something, a picture to start labeling some of these parts. We can figure out how to solve it. So let's start at the beginning here where it says roadways. So we have like a road. Roadways N and M start at the same point. So here's the point. I'm just going to make a point. This is important. They're perpendicular to each other. We know that perpendicular means that two lines are going to cross each other at exactly a 90-degree angle. So if they start at the same point, they need to make a 90-degree angle. So maybe here I have roadway N going this direction, and roadway M could go this direction. Do you see how they start at the same point, but they are perpendicular to each other because of this 90-degree angle right here? So roadway N is 44 meters long. So let's just put that right here, 44 meters long. It says the distance between the endpoints, so the end of the road, the endpoints N and M is 125 meters. So if this is the end of this road and this is the end of this road, the distance between them is 125 meters. And we're asked, how long is roadway M? Remember, this was M. Now, once we have a picture, we can say, oh, now I know how to solve that. That's pretty easy. It's just a triangle. So here we have our A and B, and then this is our C, our hypotenuse. So let's set this up. A and B. We'll just call the M this road A. B is 44. And C. Now I know that once I start typing these into the calculator, they're going to be really big numbers. So what I'm going to do to get A by itself is I'm just going to say, I'm going to subtract 44 squared. See what I did there? And then I have to subtract 44 squared on this side. So A squared is equal to, now I can type this in my calculator, 125 squared minus 44 squared. And if you do that in your calculator, it should tell you 13,689. It's much quicker to do it this way. Now, of course, I have to take the square root of both sides. Now, it's really nice that this actually comes out to a perfect whole number, which means that this is rational. It actually comes out to exactly 117. So the length of roadway M is 117 meters, which, if you look at this triangle, this should be the longest side. It's 125, which makes sense. So roadway M, there we have it.